This is Algebra 2 with Trig, 3b.2a. We're going to be adding and subtracting rational expressions. So what we're looking at here is common denominators. So here we have our denominators of c. So if we're going to add our fractions, we're just going to say a plus b over the common denominator of c. You do not add denominators. You just move the common denominator along. Same thing for subtraction. Whatever your a value stands for minus whatever your b value stands for over your common denominator of c. So here's an example with our numbers. We have common denominators. So we're going to add the 3x and the 7. Since they are unlike terms, we cannot combine them at all. We call it 3x plus 7 over the common denominator of 5x squared. You cannot reduce. Here we have minus. As long as the denominators are the same, you know what the denominator is going to look like. That's not going to change. The numerator is going to be 9x cubed minus x squared. And yes, maybe you can factor the numerator apart, but that's not going to help reduce anything from the denominator. So we can leave it just like that. Nothing to reduce. So let's practice that. Common denominators. So we say 10 plus 2. Now those are like terms, 10 plus 2. So we can call that 12 over our common denominator. Now what makes this one different is that 12 can be made up of 3 times 4. And 3x is, of course, 3 times x. We do not have adding or subtracting involved here, so we can do some reducing. So our final answer is 4x. 4 over x. Here with letter B, more people end up having troubles with this because we are subtracting a binomial. When you subtract a binomial, it's required to have parentheses. So you can be sure to distribute this to both of the terms. So we're going to have 4x minus 7. And we distribute the minus through to get negative 3x minus 3. And this is all over our common denominator. Then we collect like terms, which is x, and negative 7 and negative 3 is negative 10 over x minus 2. Now, we talk about this every time, but I still have people doing it. You cannot reduce the 2 and the 10. Because of the minus, the x minus 10, you cannot reduce. They're two binomials. Nothing's going to reduce unless the binomials are completely the same. Here again, we have common denominators. So we're going to have a 3x squared. 4 minus 1 produces a 3. I notice that the 3's can cross off. Notice there is no plus or minus. I don't have binomials. Everything is being held together by multiplication. That I can reduce. So since there's nothing left on top, we leave it as a 1 over x squared. this next one, you cannot reduce the x squareds in this case because the denominator is a binomial. The denominators look the same, so it's x squared plus 1. The numerator would be the 2x squared plus 2. Again, you cannot reduce any part of that the way it's written. But you might notice that you have this GCF in the top. And if you take a look at what happens when you factor that GCF out, it matches the entire binomial that's on the bottom. So the entire binomial can be crossed off with the entire denominator. And this is just going to leave the number 2. So that's what we have with common denominators. That common denominator just slides through. We collect our like terms, reduce if possible, now we're going to have unlike denominators. To add and subtract rational expressions with unlike denominators, find a common denominator. Rewrite each rational expression using the common denominator. So, for example, over here, our denominators are different from each other. So, to make them the same, they would have to be the product of each other. That's the only common denominator that we can get, a C and a D. And the only way to bring them together is through multiplication. So we're going to multiply this fraction. You have to do it to the top and the bottom because you're multiplying by a value of 1. That doesn't change the value of the fraction, just makes it look a little bit different. So that's going to give us A times D over C times D. I'm just writing the letters in alphabetical order. Order doesn't really matter. Now the second fraction, it doesn't have C and D as a denominator, so can I get it there? Can I get it to look like CD? And I would need to multiply by C, so I have to do that to the top and the bottom. To keep the fraction balanced, I have to multiply the numerator and denominator. So this was BC, and this would be CD. So to add those together, I add my numerators together, and I bring over my common denominator. You cannot reduce the C's, you cannot reduce the D's. So our next one, the same idea. I'm going to multiply by D to the first fraction, C to the second fraction, because that would make the denominators the same. So I'm going to have AD minus BC all over our common denominator of CD. And nothing can be reduced there. In this example, we can handle this in two different ways. It would be possible to use the exact same method we used before. The denominators are different, so I'm going to multiply this one by the 4 and this fraction by the 6, just like we did before. This makes 4 over 24. This makes 6 over 24. No need to simplify those fractions or else you're right back to where you started. When you add this together, we get 4 plus 6 is 10 over our common denominator, which is 24. Now what you probably notice is that the numerator is made up of 2 times 5. The denominator is made up of 2 times 12. There's no adding or subtracting going on, so I can cross those 2's off, and my final answer is 5 over 12. So notice how we simplified our answer. Well, if we take into account that 6 is made up of 2 times 3, and 4 is made up of 2 times 2, they both have a 2 in it already. So over here, what I need to multiply by is that second 2. They both have a 2, but they don't both have 2 2's. So I'm going to multiply this one by my additional 2. On this side, it's missing the additional 3. So what that gives us is 2 times 1 and 3 times 1 over my common denominator of 2 times 6, which is the same thing as 3 times 4, which is 5/12. So you notice that we got the same answer. We were just a little bit more strategic about what our denominator was going to be. And we only multiplied by the missing. We did what's called the least common denominator rather than just a common denominator. So the LCD is an acronym for least common denominator. We're going to look at each term and we're going to multiply its numerator and the denominator by what's missing from what we're looking for our least common denominator. We're going to rewrite each simplified numerator over the least common denominator. We do need to be sure to distribute in a negative. If you have a minus, like one that's over here, you do have to be sure to distribute that in. We're going to leave the denominator in factored form. Leave it factored. Then we can add and subtract the numerators and put it over the denominator. So notice our denominators are not the same. So I'm going to factor apart. I'm going to break apart my 10x. What can 10x be broken into? Can be broken into a 2x and a 5x. A 2 and a 5. This denominator has a GCF in it, which is a 5x, and that would leave us with an x minus a 2. Now we can look at this one and we notice that both denominators already have a 5x in it. So I don't need to include that. What does the first fraction not have? What's the extra term the first fraction needs? X minus 2. So we're going to multiply the top and the bottom by the x minus 2. What does the second fraction, what does its denominator have missing?
The 2x.
The additional 2x, right? Yes, I know the numerator has a 2x. The bottom does not have a 2x. Now, some people get confused and they say that it has an x and a 2, an x minus 2. Is that the same thing? No, it's different. We need an actual 2x in that denominator. So to put it there, I also need to put one on top to keep the fraction the same. So now I'm going to distribute through to get 3x minus 6 and multiply over to get 4x squared. Now I've taken this time to break apart my common denominator. So that's going to be 2 times 5, which is 10x squared, times x minus 2. We don't want to keep multiplying it together. We want to keep them separated. But we can multiply those two binomials, the 2x and the 5x together. That would be common. Now we'd probably reorganize this into 4x squared plus 3x minus 6. That doesn't factor apart. Nothing multiplies to be 24 and adds to be 3. All right, you can make it 5, you can make it 11, you can make it 10, you can make it 2, but you can't make it 3. So 10x squared, x minus 2. Notice you cannot reduce any parts of this. All right, for our next one. Notice that we have 3x minus 15. That can be factored apart. Has a 3 that goes into both of those numbers. Now this numerator, sometimes it's beneficial. Sometimes you just got to try it. That it has a common or a GCF that can come out of it. Greatest common factor. Now the only reason that that's beneficial is because its denominator can also be factored. And I'm sorry, this is going to actually be a 1 because I pulled the 2 out in front. So 2 times x makes 2x, and 2 times 1 makes 2. What am I going to multiply by to get to 5 but add to 4? 5 and 1 multiplies to be a 5 and can add to be a 4. That means one of the numbers has to be negative. So if I have a negative 5 and a positive 1, they would still multiply to be negative 5. They would add together to be negative 4. This kind of showed me that I had a common value that could cross out in that fraction. So now, when I subtract these two fractions together, notice that they both have an x minus 5 in the denominator, but this denominator also has an extra 3. This side doesn't have the 3. So I have to multiply the top and the bottom by this extra multiple of 3. So that's going to give me 6. So I'm going to have x minus 6. And my common denominator now is going to be 3 times x minus 5. Nothing can be crossed out. You cannot cross this 3 off with the 6 because the 6 is part of a binomial. So you go ahead and try this one. You can pause the video, you can work through this, and then play the video, and we'll talk you through all the steps. So what I notice is my denominators are different. So I've got this choice of what I should do with this common 2 that's between these. I could wait and reduce it at the end, or I could reduce it now. Most of you probably didn't reduce the 6 and the 10 at this moment, so I'm not going to reduce it at this moment. We can reduce it later. Doesn't matter. So I'm going to notice that my 10 is made up of a 2x and a 5x. Here we have 5x and x plus 1. You might notice now that you can reduce the 2 and the 6. But most of you probably didn't do that. You probably multiplied this fraction by 2x to the top and the bottom because its denominator did not have a 2x in it. They both have a 5x. Bless you. And this denominator does not have the x plus 1. So that leaves us with a 6x plus 6. This side is a 4x squared. And my common denominator has a 2x, a 5x, and an x plus 1. So most of you are going to notice when you rearrange this that the numerator has a common value in it. It has a GCF. It has a 2 in every one of these terms. And the only time that that's beneficial is if there's an additional 2 sitting down here. That's 2 times x times 5x times x plus 1. Those 2's can cross out. So you're left with your x squared plus 6x plus 6 and your 5x squared x plus 1. That would be your simplified form of adding those two fractions together.
Wait, how did you get the x squared? I thought it was 4x squared.
Good call. If this was a 4 and we factor the 2 out, we'd still have a 2 sitting in here, wouldn't we? Oh my goodness, I totally messed that up. We pulled the 2 out, so it would have to be 2 times 2 makes 4, and 2 times 3, and 2 times 3. Good eyes. Thanks for noticing. And nothing multiplies to be 6 and adds to be 3. It can add to be 5, it can add to be 2, but it can't add, or 1 actually, but it's the best we got. All right, our last one. Going to factor my denominator. Nothing to do with my numerator. Put that in parentheses if you want, because you got to remember to distribute the negative in. This gets you to be x minus 2 and x minus 1. Those multiply together to be positive 2, but they add together to be negative 3. Notice that they both have an x minus 1 in them. The denominators have something in common, so we don't have to multiply by that. This one does not have the 4 in it. And this one does not have the x minus 2 in it. So this is going to give us x squared minus 3 and minus 2 is a negative 5 plus 6. Now this is where it gets tricky. You've got to distribute the negative. I'm kind of doing 2 steps in one here. Distribute the negative to make that a positive 5 times 4. So that's a positive 20x. A positive 2 times 4, which is plus 8. And my common denominator is 4, x minus 1, x minus 2. Then we finish this up by collecting like terms. We have our x squared, our 15x, our plus 14, it looks like that top one might be able to be factored apart into 14 and 1. They'll both be positive. Nothing reduces with the denominator, so no need to factor that. There we are. In the homework, we're going to find the least common multiple. So these are acting like denominators. We're just trying to get the denominators to be the same. So what we're going to do is break these down into the smallest factors we can. So 2 times 2 times 2, that makes 8. Maybe I went overkill and I broke it all the way down like that. But I did. 2 times 2 times 2 is 8. 8 times 3 gives me my 24. Right? And I have my x times x. So those are all my factors of 24x squared. What are my factors here? Well, I can factor out an 8x, and I'm left with an x minus a 2. You agree with that? So that 8 is really 2 times 2 times 2. There's my 8. I have an x in common, and I have an x minus 2. So those are my 2 factors. This was of the 24x squared, and this was of the 8x squared minus 16x. So I factored those 2 completely down. They both have a 2 that's the same. They both have another 2 the same. They both have another 2 the same. So I'm going to need that 8. I don't need to do 8 times 8. I don't need 64. But to have the denominators to be the same, they both need to have a 2 times 2 and a 2 in it. They both need an 8. Now, one of them has a 3. So this is kind of like going camping. If you go camping, you need to take what's ever needed by one of the partners. So they need a 3. You've got to bring a 3 along with it. They both need an x. So you're going to bring an x along. One of them needs 2 x's. One of them needs an x squared. So you've got to bring an x squared along. And then one of them needs an x minus 2. So 24 x squared times x minus 2 is my LCM. Least common multiple. Let's try that one more time with this one. We know that this is x minus 5, x plus 5. So that's factored apart. This one is an x. This one is an x minus 5. What is going to make all the denominators, or it's called the least common multiple, but what's going to make all of these the same? I can't get rid of parts. What does this not have that those have in it? This has an x plus 5. That's an extra one, right? So essentially, you could come in here and write x plus 5 and x plus 5. You see how they all now have an x plus 5 in them. Do they all have an x minus 5 in them? No. Do they need to all have the same thing in them? Yep. So this one already has the x minus 5. This one does not. So this guy needs an x minus 5 in it. This one already has an x minus 5 in it. So you don't need to put another one there. Now are they all the same? This one has an extra x. So that extra x is part of your LCM. So my LCM is going to be x times x minus 5, x plus 5. Let's look at this one last time. We have our 9x squared minus 16. That can be factored apart into 3x minus 4, 3x plus 4. This one, which is 3x squared minus 2x minus 8, it can be factored into 3x times x. 3 times 4 is 12. So no, I think it's going to be 3 times 2. 3 times 2 is 6. It's got to be a negative 6 and a positive 4. And that's going to add to be, I did that backwards. 3, that's 6. Yeah, negative 6, positive 4, that's right. Okay, so those are my two factors. Are they both the same, the top and the bottom? No. What do they both need in them? What's my LCM going to be? They both need a what? They both need an x minus 2. What else do they both need? They both need a 3x minus 4. And is there anything else that they are both supposed to have? 3x plus 4. Now, if you want to go through there like I did in the previous one and say this one is missing the x minus 2, this one is missing the 3x minus 4, I think that helps. I think that helps you keep it organized.